Yeah, hello everyone. My name is Gábor. I work for Alice, and as at the bottom part, infrastructure of application development. Yeah, I used to study electronics at the technical high school. I had days like this. It was fun. I would also like to mention that my father was an electrician at the transportation company, and he also had some hobbies at home. So we were playing with the coils and stuff like that all around. And why I'm mentioning this is that this played a huge part in my career not being a question even when I was a child. So he engaged us so much in making things work, and in the best Balázs, taking things apart and things like that. And now I have two kids. They are extremely cute. I didn't bring them here now because it's too late. No, they're away. And you probably know these busy words. They are called Meetup in Hungarian. Kids just love them. You can just let them sit there and they can punch their fingers and scream around. It's fun to make and it's fun to play with. But I thought that, hey, let's make some busy work with components like this because I know some electronics and I'm missing it a lot, so let's do something at late night at the kitchen table and things like that. I hope you know these components, right? I guess. It will make sense. Yeah, because kids like to play with these buttons and stuff, and that's entertaining. So I connected these with this little piece. How many of you know this board? Yeah. Nice. So if we are talking about transistors, we have a range of things to choose from. How many of you work with this VIC microcontrollers? You should not. Forget those. Enter the world of modern stuff to play with. I hope you know all these, right? And who has these at home? Who wants to have these at home? So, in case you don't know, these are quite different animals. The bottom one is the Raspberry Pi. It's a full-blown computer. It runs Linux. It has network connectivity and all that kinds of stuff. The other one is Arduino. It's for playground purposes. Basically, it's a much smaller computational capacity. It has very limited memory. It's called microcontroller for the sake of living. So it is designed to be embedded in some environments. And we have these ESPB stuff. I put them in the middle. They are quite powerful, but they still don't. So they don't run an operating system. Basically, it's not a computer, but they are quite powerful and quite cheap. They roughly cost the same money actually as a PIC microcontroller, but they have Wi-Fi. The upper one has Bluetooth, and I think they tick at the gigahertz range.
80 megahertz. 80 megahertz, I think.
Okay.
Gigahertz is for the Wi-Fi.
Okay. Thanks for the correction. The not so good part is that you basically have to program these in C for assembly. In short, of course, you can have some translated stuff, but yeah. I don't know what the next slide is. Yeah, so how did I connect this stuff? I don't know how many of you know how these ladder arrays work. It's on the picture. So basically, for an LED, you would have to have two wires for each, but it would just be too much. And basically, they arrange them in rows and columns. And in order to make an LED light, you have to activate the corresponding row and column wires. Now you might ask, how does this let you control each piece by one? And the answer is that it is iterating per row. So it's basically a really fast blinking of the rows. You can actually see this if on the trend you have that LED-based information bar, and if you move your head around, it tilts.
Just take a photo. Take a photo.
Or take a photo, yeah. That's basically because your head will. So by the time you see the other row, your head is already a bit to the side, and this will make the row tilt. This is how all LED stuff that you see around works. Actually, even at the microwave where you have the clock, if you move your head around, the numbers will just bigger. Basically for the same reason. Yeah. Now to make this work, you would also have to add a bunch of controlling transistors and resistors and stuff like that, but you don't want to do that by hand. So you have these ICs here, which you can buy for pretty cheap. They can control the LED drive stuff with the right parameters, and you can control these digitally, I think, through I2C, probably. I don't remember. Yeah, and the good thing about these that they can be connected in series, so you can push the information forwards, and I think they have an internal clock to just do the iteration of the stuff.
That should be SPI, I think.
I think I used I2C. I'm not sure. I can check the code. Yeah. Yeah, so you have these protocols that you can use on the wires to communicate with ICs. One standard is I2C, also SPI, or you might have seen a CAN-bus in vehicles. Yeah. Yeah, I will talk a bit later about how you actually control these things from the microcontroller. Yeah, the fun part about a microcontroller is that you have these pins where you can have, so that you can use these as output pins to just communicate the way you want to with any IC that you have. Okay, do you know how keyboards work? They basically have the same thing that they arrange, so these numpads will arrange the switches, the buttons to columns and rows, and if you want to see if number 5 is pressed or not, then you put a voltage on row 1, and you check on core 1 if the voltage is there, basically. This also means that you can have inputs from all the buttons at once, but this can be done by quick iteration. Basically, similar thing is used in your keyboards too. Many keyboards don't allow you to press a specific combination of buttons at once. There are specific keyboards especially for that use case if you want that for any reason. You are music composer working on a keyboard for some reason, or I don't know. The most common style that you will ever use can be pressed simultaneously, but some keyboards just won't detect. Because if you, for example, press I can make it up. Yeah, so to work with these buttons and LEDs, you would have a lot of various to work with. And if you have seen the small microcontroller, I think it has 16 outputs at most, probably. So you don't really have space to control these, even this stuff. So for the rescue, we have a multiplexer. How many of you have seen our multiplexer? Yeah. I love looking at data sheets. They are just so awesome to read through, and all the bits and the communication. My favorite ones are the timing diagrams. They are just so nice. But for you to understand, the most important part is the architectural value. Basically, the multiplexer, this one specifically, lets you have 16 independent outputs or inputs, and you communicate with it on I2C. This one, so you basically have two wires for the communication with the microcontroller, and then you have 16 outputs. And it's awesome, and you can also put this in, so you can have multiple of these because this can have addresses. Yeah, timing diagrams show you what signals you have to send to communicate with it, but actually it's a standard one, so you don't really have to worry about that. You just download the library for that and it works. Yeah, so these multiplexers will allow me to have more output pins than my controllers would have, or input pins. You can basically program these, which pins should be inputs or outputs, and it's fun. Okay, so this is my, I don't know how to categorize this diagram, but I created this to, for myself as a reference to remember where stuff has to be connected, because it's quite easy to forget. I have 16 push buttons at the two sides. I have a big LED matrix, big LED matrix at the top. Do you have the board around? Yeah. And I have 12 LEDs in the middle. Yeah. And two numpads and switches and the segmented output. It looks quite awful because when we were moving, I taped it and it didn't come off, unfortunately. But the kids do, so it's not that much of a problem already. So basically that's it. I think we can move on from here. Yeah, so how did I do that? I had to program in C. Now if you start working with Arduino, you might get guided to the Arduino IDE. It's okay for getting started for writing simpler code, but you quite early will grow out of its limitations. You can have a plugin for VS Code. It already gives you much more features, but at least back then when I was working on this platform, was a good choice to have some tooling and scaffolding around your project. I still recommend it, even though I haven't used it in 4 years, but it's still around actually. Yes, so you write code in C, you connect it to your computer with USB, and you can just upload code and it will work. It's fun. Yeah, one important feature is that with this thing is that it can turn the sound off. The picture there might not be seen, there's a drum kit as a gift from the grandparents, and I think you can identify the parents in the picture. Yeah, so how did I do that? At the left side, you can see a Node.js application returning the time as plain text. Why did I do this? Well, every HTTP server that you address will return the time for you, but I didn't want to parse that string in C. So I created a service that returns the time for me in a format that I can more easily work with. It can be hosted on cloud and for free, basically, if you have a personal account. The other code piece right down in the middle, it's the code function to play a tone, and it incorporates the time checking. So if we are out of the allowed time, it doesn't make any noise. Also, I created it in a way that if it cannot connect to Wi-Fi, then it's also silenced. So it won't make a sound now. Yeah, this is just a simple code piece of how I read digits from the numpad, I think. So you basically iterate through the columns, and for each columns you connect the column to low. Is that right? Yeah, and I should have read the code piece before the presentation. But I think you get the idea. You have to iterate through all these and check where the stuff are there or not. I also have this small code piece which, so these buttons here play the C major scale if you press them. I can show it right now, and it's done by this little piece. I didn't really abstract away the hardware related stuff, so you can see some binary operations here. That's not a nice structure of code. Yeah, and this is how it looks. And the other stuff, yeah. So it looks a bit messy. I didn't want to create a PCB just for that. PCBs are expensive, and if you start patching over PCBs, that's wasn't that fun. But for the risk, you have these DuPont wires that you can use for connecting things. They can come apart quite easily, and we have these boards that you see on the left side, where I did the multiplexers. So these are the tools that I have used to make the thing. The board in the upper half and the other board are quite useful for prototyping. I don't know how many of you have worked with these. You can just plug stuff in, and the groups that you see on the top and the bottom there are connected, so you can easily make connections and stuff around. And In these other ones, if you are confident enough, you can solder stuff. Yeah, I didn't use a digital oscilloscope because I don't have one. I just use the multimeter to see where the signal goes. Yeah, I put it there. It's a tool I have used because I wanted to emphasize that any small code piece you write for any kind of hobby stuff, just put it on Git and push to GitHub. It will help you have branches of experimentation, and you won't lose track of all the code that you have written and commit and push and branch and do all this kind of stuff often. And you can also easily continue your work on other computer. Yeah, now I think I should be showing something to you. I have to admit that I played with this more than the kids. Let me just try to comment this. I did it in a way the plan was to have this thing out, and then the kids can connect it to a power source. And yeah, I'm not sure if you can see it. I just have one game on it now. Basically, yeah, I structured the code in a way that you can add programs on it that react to buttons and stuff that run, and they can run in parallel actually, so you can write the programs for these visually, and then they can work in parallel. Now, you can move this stuff around if it would work. Now we have to let me restart it right into the They don't.
Yeah, I know that feel.
I don't know what you're talking about.
Somebody must have sabotaged in the audience.
Yeah, I said to not touch it.
So I guess, Gábor, when you have the kids, you had a backplate so they cannot mess it up?
Yeah, I had it on. Yeah, actually, the first time I showed this to them, they just smashed this inside by the first touch. So it wasn't a big stuff.
Something.
Yeah, it is getting even worse. Oh, it moved. Yeah. So you can move these.
When did you fix it?
I don't know.
I don't care if I have you tried to turn it off and on again? Can they alive?
They overlap.
Oh, wow.
And you can change. You should be able to change.
Oh,
There's another tree. There's a man. There's a house. There's a dog. And it's truck, actually. It's a truck that can move around. I also have a small web page that I can just deal these, and we designed these together with the kids, and they were playing like just moving these around, and they were so enthusiastic when they collided and they were chasing each other and all this kind of not like a PS3 or something like that. That's what I can provide for my kids. Yeah, so and I have to admit that after this I haven't spent the time I originally planned to let this. You can switch on these segments if these would work, and you can move around so that they can play with the segment of display too. Yeah.
Oh, don't break.
Questions? One, great.
What do the switches do? They are fun.
Yeah, you can switch them around, but they don't have effect now. Yeah.
Don't you have any pictures of the kid, of your hopefully cute kids playing with this?
Yeah. Shall I? Please.
Please.
Yeah, let me just. Stop the cast for now, and because I don't want you to look around all my. Because I make a pictures of the. That's briefly after the moment. The stuff in, yeah.
Looks cute on the picture.
Yeah.
It's not the same, isn't it? The scratch is on this side.
So Gábor, I say that you are very conscious about which pictures you show, but you are very not conscious about showing very little.
I'm already not living there.
You live there, really?
Yeah.
Oh,
Not anymore.
But the house is for sale.
Any more questions for Gábor? Then thank you so much. I was expecting that.